Chapter 22, Alkanes and Alkenes. In this chapter, we're going to study about the structure of alkanes, property of alkanes, as well as structure of alkenes, property of alkenes, and how alkenes are produced by cracking, and last but not least, comparing alkenes, and learn a bit more about fats and oils. Now, this chapter is divided into 3 different videos because of the length of the chapter. In the part 1 video, we have the structure of alkanes and the property of alkanes. In this section 22.1, we learn about the alkane homologous series, which is the whole family of alkanes. You learn about naming the first 4 alkanes, the characteristics of the alkane homologous series in terms of their reactions and physical property, as well as draw the structures of the first 4 alkanes. And we also need to learn a bit about the isomerism and identify isomers. Now, what are alkanes? Alkanes are hydrocarbons that contain only carbon-carbon single covalent bonds. Alkanes have the general formula of CnH2n plus 2, and this formula goes for all members of the alkanes family. And their names all ends with A and E. For example, the first member methane, second is ethane, propane, butane, and so on. Now, each member differs from the next by a CH2 unit. And this, very importantly, applies to all homologous series. In other words, regardless of which homologous series, each member will differ from the next by a CH2 unit. Now, looking at this table, let's take a look. First member, 1 carbon, number of carbon atoms. 1 carbon is methane, followed by ethane, followed by propane and butane. And because of the general formula CnH2n plus 2, when n is 1, okay, the H should be 2n plus 2, which is 2 times 1 plus 2 is 4, so you got CH4. And for 2 carbon, when n is 2, 2n plus 2 become 6. That's why you have C2H6. For propane, when n equal to 3, 2n plus 2 means 2 times 3, 6. 6 plus 2, 8. That's why the formula C3H8. And butane, n equal to 4. So 2n plus 2 is 2 times 4 plus 2 equal to 10. That's why butane has a formula C4H10. And just now we mentioned about each member differ from the next by CH2. Isn't it from CH4 to C2H6? There's an increase of a CH2. And from ethane to propane, C2 to C3, H6 to H8. So there's also an increase of CH2. And so on. So next one also increased by a CH2. So it is true that each member differ from the next by a CH2. Structure formula. So methane structure formula is CH4. Each dash refers to one pair of simple covalent bond. For example, carbon has 4 valence electrons, so you have 1, 2, 3, 4. In methane, carbon joins with 4 hydrogen. 1, 2, 3, 4. So, this is the dot and cross diagram of methane. And each pair of shared electron is represented by 1 dash. So when it becomes structure formula, you simply draw a dash to show a shared pair of electrons. So ethane, C2H6 is drawn this way. Whenever you draw structural formula, please check that each carbon has 4 covalent bonds and hydrogen has 1. So alkenes are saturated hydrocarbons. Hydrocarbon means it contains hydrogen and carbon only. Saturated means it does not contain carbon-carbon double bond. So only contains carbon-carbon single bond. When there's carbon-carbon double bond present, you can add atoms or molecules to this particular unsaturated molecule. For this case, you see, in this methane, all the valence electrons are used to form single bonds. Hence, you cannot add any more atoms to it. And each member differs from the next by a CH2. So what is isomer? Isomer are molecules having the same molecular formula, different structural formula, very important. Isomers have different physical properties such as melting and boiling point. For example, butane has boiling point of minus 0.5 degrees Celsius. Methylpropane, which is another isomer of butane, has a boiling point of minus 11.7 degrees Celsius. They both have the same molecular formula of C4H10 but different structural formula. So this is how they look like. Methane, butane has a straight structure. Methylpropane has a branch structure. And this group down here is called alkyl group. Alkyl group is another family. There's a general formula of CnH2n plus 1. And these are branch. Why is it a branch? Because if you draw the formula, the structural formula of CH3, you realize that you need 4 hydrogen to form a complete molecule, but it doesn't have 4, it only has 3. So this particular branch is joined to another part of another molecule. Likewise for ethyl and so on. If you draw out the formula, you realize that actually it requires 6 hydrogen. But because something is missing here, this actually alkyl is actually a branch of another molecule. Next, we'll learn about properties of alkanes. Now, alkanes have low melting boiling point, insoluble in water, and generally soluble in organic solvents like oil and alcohol. How do the physical property of alkane change going down the series? Going down the series means going from a small molecule to the larger molecules down the family. First of all, molecular size increases. Because of increased molecular size, there's increase in intermolecular force. And as you know, when there's increase in intermolecular force, you need more energy to overcome the intermolecular forces of attraction. The melting boiling point hence increase because of the need of more energy to overcome the stronger intermolecular force. And because the alkanes, the chain becomes longer, it's not easy to flow, hence it becomes more viscous. More viscous refers to the less ease to flow. For example, honey has high viscosity because it doesn't flow easily. Flammability refers to ability to burn. And because a longer chain molecule, larger molecule, it requires more oxygen to burn. Hence, the flammability decreases as the molecule becomes larger. Percentage of carbon increases because of the larger molecule and harder to burn, and smokier flame also produced. So going down the homologous series from smaller to larger molecules, you realize the smaller molecules like methane can burn quite cleanly. However, larger molecules, they cannot burn cleanly, they produce more smokes. And this is some physical property of the first few members of the alkane family. As you observe going down the group, there's increase in melting point. Going down the group, increase in terms of the boiling point from very negative to positive. And because of the increase in melting boiling point, you realize the first 4 members are gases. And the 5th member onward is a liquid. So which statement about methane and ethane is correct? Are they liquid at room temperature? No, they are actually gases. Are they unsaturated? No, because you must remember the ethane, methane, all the alkanes are actually saturated because they contain only carbon-carbon single bond. And obviously this is not the general formula for alkane family. And the last one is correct. They contain carbon and hydrogen only. They're all hydrocarbons. Now, which physical property decreases as N increases? In other words, when N increases means the number of carbon increases, the molecule becomes larger. So you're talking about size increasing. When size increases, what decreases? You're right. It's the flammability. When size increases, it's harder to burn the molecule. So flammability decreases. So we learn next is the two chemical properties or reactions of alkane. First, alkanes are mainly used as fuel. They burn in excess oxygen to form carbon dioxide and water. When it's insufficient oxygen, they'll produce carbon monoxide and water instead. If it's insufficient oxygen. And because the reaction is highly exothermic, they produce a lot of heat, so they're frequently used as fuel. Fuel are substances that burn to produce heat and light. Fuels are substances that produce heat and light when burned. Next, substitution. In the presence of UV light or UV ray, alkanes react with halogens like chlorine, bromine to form a compound. For example, when methane reacts with chlorine, this UV splits the chlorine molecule, and the chlorine atoms that's being produced will attack the methane and break the bond so that the chlorine can substitute hydrogen, as in this case. So when one chlorine substitutes the hydrogen in methane, the hydrogen combines with the other chlorine to form HCl. The reaction does not stop here. When this chloromethane collides with another chlorine molecule, and this chlorine molecule in the presence of UV ray, they form chlorine atom, and this chlorine atom will now attack the other bond to form HCl and dichloromethane. Di because there are two chlorine in this molecule. And further on, more chlorine can attack dichloromethane to form trichloromethane. And last but not least, as you guessed, the last hydrogen also can be substituted to form tetrachloromethane. So chloromethane, dichloromethane means 2, trichloromethane means 3, and tetra means 4. So in this tetrachloromethane, there's actually no more hydrogen because all the hydrogens are substituted by the chlorine atoms. Let's recap. What are two important chemical reactions of alkane? Alkanes are saturated compounds and they are not very reactive. They only react with oxygen in combustion and they react with chlorine or bromine in substitution. Let's try this question. Which statements are true about alkanes? Is this general formula correct? No. Are they flammable? Yes. Can they react chlorine? Yes. But what must be present? UV ray. UV light or UV ray. So answer is actually B. Octane is an alkane found in petrol. Which statement about octane is correct? Now, if you compare octane and methane, methane is CH4, oct is 8. Okay? Now, who has a lower boiling point? Obviously, methane. So it's not lower. You have not learned about polymerize, you have not learned about decolorizing bromine, but you learned that it reacts with chlorine by substitution. So answer is D, and you should know that. This is the end of part 1 of the video.